Okay.
Okay. Can everybody see the screen?
Yep.
Okay. So I've had this need a few different times on various projects to get some like very coarse-grained profiling data on a production system. So this is especially helpful if you've got something that is like working fine locally performance-wise, and then in production you're getting something really slow. So I was getting that on Graph recently, where pages locally I was getting 200 milliseconds to load, and in production it was just getting worse and worse. It was 5-6 seconds sometimes to load a page. So I was trying to figure out what was going on. In the past, I've done something like this. So this is kind of the old hacky version of what I would do. At first, your original attempt at this, you might just like get the start time of your page and then just log out to a file at various points how much time has elapsed. Eventually, you see that you need to filter it somehow. So in this case, I pegged it to a particular session ID that I had on, like, looking at my cookies in Chrome. This gets a little messy because, one, I'm just dropping the functions directly into my project. So this is the main index.php file in Graph a while back. So sometime last year I was doing the same kind of thing. So you kind of like find these little hacky functions you've used before, and you copy them into another project or whatever you need to do to actually get some information. And again, this isn't going to get you like Xdebug level of info, but you can drop little calls to this function throughout your page and at least get a feel for, okay, it's happening during like my cart logic processing or my Zen Framework Bootstrap or something like that. You're just trying to find like the basic location of the bottleneck. So instead of kind of putting these hacks back in place and trying this again that way, I put a lot of this stuff into a little open source library. It's really simple. I probably won't spend a whole lot more time on it, but the basic idea is you can include it with Composer, and then in this case, I'm being more specific about where to find the ticker identifier, which we'll talk about in a second, but typically you would just call ticker in it, and then you call this ticker function throughout your application, wherever you want to call it. And if the person doesn't have a specific cookie, or you can use other data, but a specific identifier saying that they should be profiled, then no code is run. So it's not going to affect anything if you have these sprinkled throughout your code base. You can just leave them there if you want. So I'm actually planning on putting these calls throughout parts of Dewdrop and things like that, so you can easily see like how long various queries are taking or how long it takes Dewdrop to bootstrap, things like that. But before we dive too far into it, I want to show you just how you use it. So one of the problems in this old approach is like you pretty much just have to write out to a file. That's really the only way to get the data out, to actually be able to see it. That's problematic because the file is usually still sitting there. Sometimes you have permissions issues. It's just kind of an annoying way to deal with it. So instead of doing that with the ticker library, there's a little command that ships with the Composer library. So vendor bin ticker. And this spits out a little piece of JavaScript you can put in your console in Chrome DevTools or Firefox or whatever. And this is going to set a cookie that says, this person should get profiling data. So it's a cookie that does two things. It encodes the port that I'm listening on, because right now I'm listening for profiling data to come in on a TCP port. And it also encodes a little key. So it's like an authentication token as well to say, this person's allowed to send you data. So then I go to my console, I set that cookie, and the next time I load a page, I'll start getting events, and these are ones that are built in. It's like the start of the request, and then from the start of the request to ticker starting, how long did it take 21 milliseconds, and then to the end of the request, it took 538 milliseconds. If I wanted to get more fine-grained, I would just throw in more calls to ticker. So I can grab whatever random thing and just throw a little call in there. So do like do that, refresh again. I don't think Vagrant refreshed yet. I think Vagrant's not getting my change for some reason. Let's restart. Yeah, there we go. That was weird. So then I can see, okay, from the start of the request to completing my index action code, 744 milliseconds, and between ticker started and completing index action at 668. So you can sprinkle these throughout the code as much as you need to get as fine-grained as you want to get. So on Graph & Sons, the issue ended up being just doing item number lookups. There was a query that would try to force item numbers to lower or uppercase or something like that. And on development, because of my SSD or lower database traffic or whatever, that was a trivial amount of time. And on production, it was starting to take a lot of time. So I added a little cache around that and added an index in Postgres to index that output of that function of the lower model call. And that drastically sped up the site. It was like 3 times faster just by doing that one little thing, and this data made it very easy to find that. So you can leave this open. You can pass this to another developer and have them add that cookie so you can get more data from someone else if maybe it's particular to their session or something like that that's causing the performance issue. So it gives you a lot of flexibility in that regard to have this up and running, and then as soon as you're done, you just end the process, and now it's not doing anything extra on the production server, so it's not going to harm anything by having those calls to the ticker function in there. So that's basically it. Any questions about that?
So how does this compare to what you showed us before with Symfony Stopwatch?
It's the same basic idea. It's a little bit simpler as far as the actual call that you're making. So I've got a helper actual function just called ticker. So you don't have to add a use statement up here. You don't have to instantiate a new stopwatch or carry that around. Let me show how that works. This is very Laravel-like actually. So there's this helpers.php file. So in your project, if you want to use this at all, you can just call ticker init, and it's going to use a singleton instance of ticker. And then when you're calling ticker again, just as a function, it's going to grab that same instance. So I don't have to carry that around with me and track it. It's just kind of built in, assuming you're going to want to use one instance of this profiler. Symfony Stopwatch, on the other hand, you need to instantiate it, and then you need to carry it around as a global or put it somewhere so that you can get to it in various parts of the code. So internally, this is doing very much the same thing, but the goal is to have it be trivially easy to sprinkle this throughout your code or sprinkle this throughout Dewdrop and have it output these little checkpoints for you, basically. And then the other thing is Symfony Stopwatch does nothing with output. So you still need to grab the information out of the stopwatch and spit it out somehow. So the way that ticker is doing it is just a little React PHP daemon. So we open a TCP port, and it's a random port. Then we listen for connections on that port and output the data to the console. So it's a very easy way, without having to write to the file system, worry about permissions and things like that, to see the information. And then as soon as you disconnect, that's fine. You're disconnected. There's not going to be anything happening anymore. And then, yeah, that random port is encoded in the cookie that you use to kind of authenticate with it. So it's mostly the layer of how do I display the information and how do I determine, what request is coming from the developer that we actually want to profile versus the thousands of requests that are happening simultaneously from other people, like filter out the noise, basically. So that's why it's there on top of something like a stopwatch, if that makes sense.
Yep.
How would
Cool.
you go about installing into an existing application?
Yeah, so it's just composer require. So if I look at the Graph and Sun site, I think I'm on an old commit here. Let me flip to now and look at the composer.json. It's just this. And then, yeah, once you have that, all you need to do is call ticker init. That'll get you the request timing that I showed, and then every call that you make to the ticker function will just add another kind of checkpoint in the log there. If I was going to add anything to this, it would definitely be like a little quick start kind of thing, and then a divider in the output to kind of show different requests and the URLs that they were hitting. I don't know if I will do that anytime soon because I kind of don't need it now. But if someone wants to work on that as just like a cool little, let's polish up an open source library kind of thing, let me know and I can kind of point you in the right direction on what you would need to do. But yeah, for right now, this is mostly just trying to get to the point that I didn't have to use that little random global function hack that I had before. This is now something kind of bundled up that I can take to another project very easily and solve a performance issue. So. All right, I think that's it.
That looks like it'll be really useful.
I like it.
Cool.